Hey guys, last week we worked with the basics of sequences and a little bit of series. We're going to continue working with series this week. So in general, series, it's the sum of a sequence. And a specific member of the series is called a partial sum. So if you had the sum of the first four terms of a sequence, it will be called the fourth partial sum. A way to represent a series that we haven't shown yet is with sigma notation. So the core of sigma notation is the Greek letter sigma. It is a capital sigma. And K, A sub K. Just filling in everything. And then we'll describe it all. All right. So, sigma notation. Anytime you see this sigma, that means take the sum. So you are adding up the terms. The terms you are adding up are terms in this sequence. This is the explicit definition of a sequence. This variable and that variable should always match. I'm not going to be too picky about that, but it should. Anytime, whatever variable you define underneath your sigma should be the variable used in your explicit definition of the sequence. This number beneath here is the position you start in the sequence. Usually it's going to be 1. Almost every time it's going to be 1. But say if that was 5, you would start at the 5th term in the sequence and add up the successive terms from there. And this number n on top of the sigma is the position to end in the sequence. So if we wanted the fourth partial sum, that number would be 4. But if we had from 5 to 10, you'd be adding up those 6 terms, 5, 6, 7, 8, 9, and 10, all right, in that sequence. A sub 5, A sub 6, A sub 7, A sub 8, A sub 9, and A sub 10, all right? So that's sigma notation. This is used frequently anytime there's sums. Understanding this notation is very critical for calculus next year. So let's just try and apply a sigma notation, evaluate a sigma notation. So let's say we had sigma from k equals 1 to 5 of 2 to the k over k factorial. So we are finding the sum of 5 terms, the first 5 terms of this sequence. So the only type of series we found a formula for is an arithmetic series. This is definitely not arithmetic, so we're just going to have to brute force it. We're not going to be able to have a formula to help us find that quickly. We will have one for geometric series, and we already have one for arithmetic series, but for a series like this, just a general series that is neither arithmetic nor geometric, you just have to go through and do it. So 2 to the first over 1 factorial, plus 2 to the second over 2 factorial, plus 2 to the third over 3 factorial, plus 2 to the fourth over 4 factorial, plus 2 to the fifth over 5 factorial. So that's 2 over 1. That's 4 over 2. That's 8 over 6. Oh, and for those of you who don't recall factorials from last year, it's the product of every positive integer up until that integer. So this is 1, that's 1 times 2, that's 1 times 2 times 3, 1 times 2 times 3 times 4, 1 times 2 times 3 times 4 times 5. So 2 to the 4th is 16, and 4 factorial is 24, 2 to the 5th is 32, and 5 factorial is 120. So that's 2 plus 2 plus 4/3 plus 2/3 plus 8 4/15, I believe. All right. So 2/3 and 4/3 is 6/3, which is 2, so it's 6 and 4/15. It's 90, 94/15. All right, there we go. So that's the sum of this. That's how you would evaluate this sum. This tells us evaluate the sum of that sequence, the first 5 terms. Now there are some properties of sums that are very useful. So for these properties, we're just going to let C be an element of the real numbers. So our first one, if we have a sum of just a constant, really all that's saying is C plus C plus C plus C over and over until you reach n times. So it's really just C times n. So if you have the sum of a constant, it's just the constant times the number of times you're adding it. If you have a constant times an arithmetic sequence, then it will be CA sub 1 plus CA sub 2 plus so on and so forth. So you could factor out the C from there. So it would just be the sum of the sequence times C. If you have a constant, you can factor out the constant from the sigma. And then there's one more property that's going to be useful to us. And that is, if you have a sum of a sum. Well, if you stretch that out, it will be A1 plus B1 plus A2 plus B2, all the way until AN plus BN. And this is all addition. So commutative and associative, we can reorder and regroup. So reorder so all the A's are together. And reorder so all the B's are together. Should give myself a little more room, whatever. So that's the sum of the first sequence. And that's the sum of the second sequence. So if you have a sum inside your sum, you can break it up as a sum of two sums. I know that's a lot of sums, but sometimes sum is what you gotta do. All right. So, that's it. That's it for general series. That's summation notation and how we can use it. All right, have fun.